Okay, guys. Well, there's two really nice extensions to the t-test. One of them is called a two-sample t-test, and one of them is a paired sample. What's it called? It's called a paired samples. And the essential difference is one you can do on your calculator using a two-sample t-test, and the other one you can do by taking the difference between paired values and then doing a one sample t-test by considering that the differences should be equal to 0 if there's no difference between the two populations. Okay, so the two sample test doesn't necessarily need to have the same number in each sample, but the paired sample test definitely does. So that's like one where you're saying, okay, we've got 10 people, they've all taken the physics test and the maths test, and they have those 10 results each, and we can look at the difference between those two things. So that's a paired sample one. And clearly, if you took the differences, you'd be expecting them to equal to 0 if the tests come from the same underlying populations, essentially. Okay. Anyway, that's the second part. So the first of the two tests is the two sample test. And again, actually, this is pretty straightforward, but it's also quite nice. So we need to put in all of this information. I don't know if I'll do this actually. All of this information. Perhaps I'll just pause off the video. I figure it's pretty boring. So put in all of this information for group 1 and group 2 into two columns. Tell you what, I will pause off and I will do that. Okay, so I'm back. I've got my information in here. I've typed all of this information into the calculator. So part A says, write down the null and the alternative hypotheses. So in this case, we're thinking, is there any difference between Mr. Arthur's two chemistry groups? And so we're trying to see if the means are different. So that will tell us whether or not one has got a higher achievement or the other one's got a higher achievement. Okay, so in the null hypothesis, they're the same. So mu1 equals mu2. And of course, the alternative hypothesis is simply saying that they're different, so that they're not equal to each other. We don't think necessarily that one group is better than the other. We don't know at the moment because we just have information in a table. Now, if Mr. Arthur thinks definitely one group is much better than the other and has got the averages for both of the groups already, then he could do a test which was a one-sided test, but in this case, it's a two-sided test, because that's how it's set up in the first place from the statistic, from the raw data. Okay, then it says perform a t-test at the 5% significance level. So I'm going to go to menu, I'm going to go to statistics and stats tests. I want a two-sample t-test, so it's the fourth option in the TI Inspire. That's what I'm up to at the moment. I'm genuinely doing this in the background. Okay, so I'm going to go data. So okay, and so list 1 is in A. I didn't rename anything. And list 2 is in B, so B and then control and the square brackets. Frequency is 1, so each of these results occurs once. Frequency in list 2 is 1 as well. The alternative hypothesis is standard. It's set as mu1 is not equal to mu2. And this is important. It says, do you pool the data in terms of the variances? Do you assume that both of the groups have the same variances? I think that's what it is. If you are given the choice between pooled and not pooled, select pooled. This assumes that the variances of the populations of the populations the samples are taken from are equal, and is the assumption that will be used in the examinations. So you have to go with pooled. So for you, you're going to say yes to pooled. So you need to change that in your calculator. So yes to pooled. So results column C, I don't want to draw anything. And so I've got that in now. So next thing to do is look at my p-value. My p-value is 0.81622, something or other. So to three significant figures, this is what we have. And we can clearly see that that's nowhere near 5%. So it would need to be underneath 5% in order for us to accept the alternative hypothesis in this case. And so we're going to reject the alternative hypothesis and stick with the null hypothesis in this case. There is no significant difference between the two groups. Okay, that's that. That's the two sample test. It's super simple. You put in the two sets of information. It's a t-test because you don't have the standard deviation of the underlying population. You know, if you did this year upon year upon year, it'd start to build up information potentially for the population, for what students should achieve. So we need to use a t-test for this. Okay, so let's look at one which is a paired sample. So paired samples essentially can be a one sample t-test by this little alteration. So looking at example 10 here, you can see in example 10, they say 5 candidates attended a revision course hoping to improve their chemistry grades. They were tested before the course started and again at the end of the course. The results were as follows. So in this case, we want to know if they've made any improvement, I think. So let's see, determine at the 5% level whether the course improved the candidates' performance in their chemistry tests. This is useful. We can see whether or not lessons, courses are making any difference. Okay, if you test at the start and you test at the end, assuming that these tests are fair tests. So, okay, so we need to put this information in. Oh, hang on. We don't need to put it straight into the calculator. You don't need to do a t-test, two sample t-tests at the moment. What we can do is say, well, the differences, the mean difference, if you like, should be 0 if there's no difference between the two results. And mu2 should be greater than mu1 if there is a difference, but that would mean that mu2 take away mu1 would be greater than 0. So that's what we'd be seeking to test here. Okay, so let's have a little look on how they're doing it. So they found the differences, 8, 17, 4, minus 1. So let's look down again. There's 8 better, that's 17 better. Okay, 4 better, minus 1, 1. And these are the differences. So this is mu d. Okay, so H0 is saying mu d, the average differences are 0, and H1, the alternative hypothesis, is saying that mu d is greater than 0. And by the looks of things, it seems like it's made a difference in all but one of those students, and in some cases, really significant differences. However, I say significant, and in fact, we need to use significance in a correct statistical sense here. So we need to perform this test. So let's put it into the calculator then. So let's go new doc here. Let's add some sheets. And so let's put in those values. Let's go 8, 17, 4, minus 1, and 1. So those are our differences. And we're going to go statistics. We're going to do a stats test. We're going to take the t-test. So we just need a regular t-test. And we're going to input the data. So that's good. And mu0 is going to be equal to 0. The list is in A, not B. I need to change that myself. And the alternative hypothesis here is that mu is greater than mu0, which is 0. Okay, and results says C here. I'm going to go with that. I don't want to draw anything. Press OK. I'm getting a p-value out of 0.07132. Okay, and you can see it's the same here as well. So same that I'm getting on my calculator. Okay. So in fact, it's saying here that that's not significant. That's not come under 5%. So even though we have 8, 17, and 4, so especially the 17 there, and 4 out of 5 people had results which were better this time round, there's not enough information there to say that this is statistically significant. We would perhaps need a larger sample size. So to a 95% significance, to a 5% significance level, this is not significant. Obviously, to an 8% significance level, it is significant, but that's not how the test was designed in the first place. Okay, well, that's that. So then there's 14I, and let's see what comes next. So next we have the chi-squared test for independence. Okay, thanks for listening.